Welcome back to the Home Lab, and I've got an interesting project to share with you today, and one you might like to build yourself. It's a retro light chasing sign. Whilst watching the FranLab channel on YouTube the other day, I noticed she made a really interesting sort of retro sign to show how these old-fashioned light chaser signs work that you used to see outside cinemas and buildings. And I really like the shape that she used. So I shared the shape of mine, but put Barry on it instead to put outside his bedroom. And the electronics she used for the light chasing LEDs was a programmable chip, and I thought that's possibly a bit difficult for some people. So I've designed a slightly simpler circuit, and I think it's one you could build yourself as well. But just before we start, I want to say a huge thank you again to all of you for supporting my channel and watching my videos. I do hope you enjoy the little electronics builds and the more physicsy content. I also want to say a huge thank you again to PCBWay for sponsoring this video and always encouraging me to make lots of new content. Now, if there was ever a video that could use their services, this is the one, because other than just doing printed circuit boards, they also do printed circuit boards where you can print a design on the front, so you can have a picture on the front. And I think this would be the ideal project for that service. Anyway, have a look at their website, and I'm sure you'll get some inspiration for your next project. So let's get started and have a look at how I built this little project. To get started, I took a screenshot from FranLab to get an idea of how to draw the arrow shape, and then massively reduced the contrast so I could just concentrate on the outline of the shape. You could of course freehand draw any shape you like. I then printed it out onto A4 and did my own Barry design on the arrow. I wanted it to be larger, so my partner kindly photocopied my drawing onto A3, which gave me a much better size to work with. I had some offcuts of 5mm foam board, so I glued the A3 arrow drawing onto this and cut it out ready to mount the electronics and to add the coloured artwork. For this, I used a surgeon scalpel blade, and this is definitely a case where using a quality tool makes all the difference to the ease of completing the task in hand, and its general quality too. With this job finished, it was time to redraw the artwork on the foam board. I felt I'd do a much better job second time around, rather than just sticking my previous artwork on top of the board. I guess you can be the judge of that. As you might guess, this was quite a lengthy task, as I did not want to make any permanent mistakes with the Sharpie pens I was using. With this done, it was time to mark out the positions of the 44 yellow LEDs, punch them through with a sharp pencil, followed by a spare 5mm LED to get the hole sizing right, and then to tidy up the holes with a sharp scalpel. Previous evenings, I'd been working on a series of simple circuit ideas to get the light chasing effect. I have built light chasers before, but these were much more mechanical and therefore extremely noisy. After much thought about the sequence of lights that look best, I settled on groups of 4 moving towards the arrowhead, with 1 on and 3 off at any one time. This was easy to achieve with a slowly oscillating 555 timer and the CD4017 decade counter chip, counting up to 4 and then resetting and repeating the process. No Arduinos required. So let's have a quick look now at the circuit that I've built, and it's fairly simple. It consists of 2 main blocks, a 555 timer that creates pulses and a CD4017 that counts those pulses and lights the LEDs. So this is a pretty standard 555 timer circuit. You can see the resistor network here and the capacitor that set the rate that it will tick at, and this little potentiometer here, or variable resistor trim pot, if you adjust that, you can adjust the rate that this produces pulses, so you can have the LEDs flashing really rapidly or not very rapidly at all. And finally, on the output of the 555 timer, I've got a little LED on the circuit board and its current limiting resistor, just to show that the 555 timer is working properly and to see what clock rate I've set. The output of the 555 timer goes into the CD4017 chip, and this is quite a clever chip. It's a decade counter. And what that means is it's got 10 output pins labelled 0 to 9 rather confusingly, so we don't have a double-digit number, 10. And as it receives pulses, it switches on the first pin, then switches that off and switches on the second pin, then switches that off and switches on the next pin, all the way up to the 10th pin, and then resets again and does it all over again. Now, what I've set this up to do is to switch on the first pin, pin 0, and to light the first set of LEDs. Then it will clock on 1 from the 555 timer, switch that off and switch on this pin and switch on the second set of LEDs, and then the third and then the fourth. But the clever bit is when it puts a voltage on the next pin, that's the 5th along, okay, that voltage will go out and back into the chip, into the reset. So instead of lighting a 5th set of LEDs, that signal goes into the chip, and when it goes high, tells the chip to reset and start again. So what it means is the first set of LEDs come on, then the next set, then the next set, then the next set, which gives that sort of chasing effect, and then back to the first set again. Now, the only other thing I've done, and it might be a little bit of overkill, but these don't provide much current. They're really only designed to provide a voltage. So because I've got quite a number of LEDs, to make it more robust, I've added a transistor switch. And this is pretty simple. What happens is that when a pin goes high, a small current flows through the base and down to here, which will make the transistor conduct and allow these LEDs to come on. As soon as this pin goes low, there'll be no current through here, so the transistor will switch off and these LEDs will switch off as well. Now, I've only drawn one LED here, but there's quite a few of them in the first set, as it were. And the second set, the third and fourth are exactly the same, but I haven't drawn the transistor circuits for those. So it's a fairly simple circuit, pulses coming in, controlled here by this little variable resistor to control the rate of the pulses, and then a decade counter that will count through each set of LEDs and then reset and do it all over again until you switch it off. With the circuit diagram drawn, I firstly built the circuit on breadboard to check it and see if I wanted to change anything. In general though, I was pleased with how the design worked. It was at this stage, and for no good reason other than to satisfy my curiosity, I decided to put the LEDs from the breadboard into the sign and wire them up with an exorbitant number of crocodile clip leads. I questioned myself as to whether I should include this in the video, as it's pictures like this which can do a lot to put people off electronics, as it all looks far too complicated. But of course, all that's happening here is I'm basically making the legs of the LEDs a bit longer so they can reach from the sign back to the driver circuit. Regardless of this, I was really pleased with the result I obtained. So I took it all apart, and it was now time to connect it to the 44 pre-wired LEDs which I need to put into the sign. It was in general an easy and fairly quick task to fit the 44 pre-wired LEDs, with all of the holes already being a snug fit. This also meant that no adhesive was needed. It's funny how so many projects, especially the ones that I choose to do, need, as part of their building phase, lots and lots of repetitive actions, and this one was no exception. But after a few minutes, with it finished, the end result was looking good and it was ready for wiring up. So it was now time to coax the LED wiring into some kind of order. I hadn't really thought this bit out in any detail, but it seems sensible to group polarities together, starting with the common anodes and cable tie them together. This produced 3 groups of wires that could then be stripped, twisted together and soldered in bunches. I then joined the 3 bunches together to the common of all the LED positive wires. The next stage was grouping of the cathode ends of the LEDs. This was not going to be as easy, as there were 4 distinct groups that had to be correctly identified and grouped to allow a running light pattern to work and, therefore, not have all the LEDs flashing out of sequence. Once done, I used heat shrink sleeving to cover the numerous soldered joints between all of the cathode wires. I had transferred the breadboarded test circuit onto a soldered circuit board that was as small as possible, ready to fit it onto the back of the Arrow. With my record of mistakes, I wired and tested the 555 timer part first, and, as expected, this didn't work. The cause, amusingly, being a dry joint on the indicator LED, caused by using a rather old and tarnished current limiting resistor. So the circuit was actually working after all. I could tell you numerous stories of situations where one should not be lulled into a false sense of security by blindly trusting one's test gear, as it could be that which is misreading or the cause of a perceived fault. But perhaps I'll save those stories for another day. As the current output from the 4017 is a bit on the low side, it tends to be able to just light 1 or 2 LEDs, I took the precaution of building a little transistor switching circuit to give increased current to the LEDs, as more than one would be on at any time. Simple as it was, I thought it'd be a good idea to test it on a bit of breadboard first, and it worked perfectly. As an aside, I think I must have had these transistors for over 35 years, and they're still working fine. I then tested the 4017 board's outputs with the BC107 transistor board, and thankfully that too all worked fine. With the circuit boards built and joined together, I could now wire up the parallel groups of 4 LEDs back to the BC108s and the 4017 light chaser circuit, hoping the sequence was wired up correctly. I then mounted the sequencer driver circuit onto the back of the sign with some sticky cable tie bases, and I did a bit of work to tidy up the wiring. I had no intention of making it look really neat or have it flush with the back of the sign. With it all wired up, I connected it to the bench power supply, and it was time to turn it on and see if it worked. And I hope you agree, it looks really good. Power supplies for these small projects have always been a bit of an issue. I thought I might build a solar circuit that charges during the day and switches the sign on at night. But in the end, I decided to take the easy option and buy a USB solar battery pack and wire it up to that. It would of course be on all of the time, but I think it looks great on the window shelf outside Barry's bedroom. Okay, turn it over. That's it, and prop it up on the towel. That's it. Connect that one up onto there. The black onto there. Squeezy, squeezy. Yep. And there we go. Put those out of the way. Now, turn on the power supply. And press the power. Switch the power on. No, not that one. It's that one.
Oh wow!
What do you think? Is it good? Do you like it? Yeah. It's a Barry sign. So if you enjoyed that, why not have a go making one of these yourself? It's fairly easy to do, and if you find the electronics quite difficult, you can buy LEDs that are pre-wired and are also flashing LEDs, which might make it a bit easier, and you could probably build that without even using a soldering iron. I also think it's a project that would lend itself very well to a printed circuit board, and I mean a printed circuit board that's got some colour or graphics on the front. And also I think it'd be much more durable if you actually 3D printed it. So I do hope you enjoyed that little build project and you feel inspired to maybe build one yourself with your own design. Thanks again also for watching my videos, and I really value the comments that you leave. I wish you could leave video comments as well and show me some of the things that you've been doing or the changes to projects that I've made. Do please take a moment to subscribe. It always helps me along and promotes the channel a little bit. And also, Do stay to the end of the video after I've finished speaking, because I always add some extra bits that I haven't cut into the major part of the video. Anyway, I'll be making another video soon, and I do hope you'll join me then.